So we've defined center-seeking forces. We've defined rotations related to gravity and the force due to gravity. And so we've seen how the acceleration due to gravity changes depending on height and how fast we need to rotate a space station. So now let's think about how things rotate. And when we have a collection of masses, how do we define that? And what this can eventually build to for all of my PT students is that how does something naturally want to move? And how we define that is we say that things will tend to rotate about their center of mass, or where is the area where the largest mass is concentrated. So things will rotate about that concentrated area of mass. And we have this mathematical way of kind of looking at it is that I can write then, let's see, my center of mass is going to equal, let's see, mass 1 times, let's see, the distance away from some axes, x1, plus mass 2 times its distance away from some axes, and then plus mass 3 times some distance away. And why do I keep saying some axes? I'm going to explain that here in 2 seconds. But all of this is divided by all of the masses occupying that space. And hopefully we've done enough 1- and 2-dimensional things that you'll see that we can take this from just x and look at it in terms of x and y. Now, why do I keep saying away this distance away from some axes? So here's the part that some of you are not going to like, is that I get to choose what is my axis? Where am I rotating things from? For this one, let's just go ahead and for the example 1, I gave you that this is defined as 0 over here. And so let's just say that that is the axis I'm going to consider. So I know that this distance is 6, this distance is 5, and this distance is 1. So I'm taking it from here. Let's see. So my center of mass is going to equal then x equals 2 times 1 meter away, plus 2 times 5 meters away, plus 2 times 6 meters away. I should consistently use units or not use units, Linda. All right. So then divide by the sum of the masses 2, 4, 6. So I have 6 kilograms. And what do I get? I get 2 plus 10, so that's 12, plus 12 equals 24 divided by 6. So what units do I have? I have kilograms times meters. Let's go ahead and write that in for each of these masses. So this would be 24 kilograms times meters divided by kilograms. So this x is indeed just a position. So what does this tell me? This tells me that the center of mass for this system is going to be at 4 meters. Check this out. So if I come over here, it's just a little bit shy of here is where it would place it. So the center of mass for this system is closer to these two. This is 5 and 6. These are only 1 away. So these are closer together. The concentration of mass is closer together. So the center of mass is here. Why isn't it here? Well, because we still have this 1, 2 kilogram mass hanging out here. So the center of mass for where this thing would naturally rotate the easiest is going to be about that point. Let's do something a little more complicated.